This lab was a continuation of Lab 1, in which we found the charge on a piece of previously neutral Scotch tape. We used a different code to determine the estimate for the charge on the tape, so we got a different value for the estimate than Lab 1. This will be discussed later. In the lab, a procedure was done in which a clear neutral Scotch tape was ripped off of another tape, so that they both acquired an equal and opposite charge. We called them U-tapes because we created a handle on the tapes in which we could touch in order to not neutralize the charge on the tape. We only used the top one of the tapes each time, which was the one that was ripped off, so that all of the U-tapes used in the experiment had the same sign charge. We found the magnitude of the gravitational force, which is F equals mg. Gravitational force equals mass times the acceleration of gravity on Earth, which is 9.8 meters per second squared, and therefore the magnitude of the electric force. This was done by achieving the two tapes to float above one another, since they repelled due to their like charge, and then measuring their separation distance. We knew that at that instant the net force is zero, so the two forces, which are the gravitational and electric force, must be equal in magnitude, but they are opposite in sign. This is due to Newton's second law, which is net force equals mass times acceleration, and since at that moment the two tapes were not accelerating, so the net force was zero. Setting F equals mg and the electric field formula multiplied by charge Q, which is the electric force formula, equal to each other, we were able to solve for the charge Q. The difference in Lab 2 versus Lab 1 was the coding. In Lab 2, we modeled the tape as a line charge. As you can see, much more is shown in the line charge model, and more is needed to be calculated. The code here, in Lab 2, shows a new function that returns a line of charge. It takes in the start position, axis, mass, charge, number of uniform point charges, denoted as n, and color, and then returns the line of charge. The code in Lab 2 uses iterative calculations to calculate the force from many different positions along the tape instead of just at the center. This is such an iterative calculation that calculates the electric field at different locations. Iterative means involving repetition, in this case repeatedly calculated something. This is contrary to Lab 1, in which electric force was only calculated one time. If we had modeled each of the tapes as a single point charge, it would be less accurate. The value from the line charge calculation is likely closer to the real value because it more likely shows the shape of the tape itself and all the different ways the electric field vectors at different positions are pointing, instead of just approximating the line of tape as a single point, causing these estimates to differ. The two estimates were 3.7 times 10 to the negative 9 coulombs in Lab 1 versus 3.59 times 10 to the negative 9 coulombs in Lab 2. They are relatively close in magnitude, although the value in Lab 2 is more precise and most likely more accurate. The value in Lab 2 was achieved by adjusting the value of Q in the code, as shown here, until the magnitude of the electric force that was calculated was very similar to the magnitude of the gravitational force on the tape. This was done by guessing and checking, but we started with the estimate for charge calculated in Lab 1. The values are printed out as shown below in order to compare them. Major physics principles shown in this lab are Newton's laws of motions, specifically net force equals mass times acceleration, attraction versus repelling, which is how like charges repel and opposite charges attract. Also, charge transfer, in the terms of how the two tapes were originally neutral but then acquired a charge after being ripped apart, and how we couldn't handle the tapes because charge from our skin could transfer and neutralize the tape's charge, causing the experiment to not work. Lastly, new to Lab 2, the fact that iterative calculations are more accurate. This is because in this way it takes into account the different directions in which the electric field and force is pointing from each location on the object instead of thinking of it all coming from one place when it is treated as a point charge. In conclusion, Lab 2 generated a model that shows several point charges on a line. It adjusted code from 2 point charges to 2 lines and computing the interaction there, and most likely getting a more accurate answer to the charge on a piece of Scotch tape.